Hey, welcome to this lesson which is about game modes. In this lesson, we're going to make it so we can spawn in at our player start. And to do this, we're going to create our own game mode blueprint class that will allow us to override spawning in as Unreal's default pawn. So in the previous lesson, we placed in our player pawn blueprint class into our level and we auto possess it when we hit play. So this way works, but notice this isn't actually using our player start actor that we've placed in our level. And look what happens if we remove the player pawn from our level and just hit play. Notice that we still spawn in as Unreal's default pawn. So what is causing this behavior? Why are we forced to play as the default pawn when we hit play? Well, this behavior is all down to a specific class known as the game mode. The game mode class controls the rules of your game. For example, if you were creating a multiplayer game, you could have your own game modes for different game types, such as a capture the flag game mode class or a King of the Hill game mode class. But of course, we're not creating a multiplayer game right now, so what else does a game mode do that applies directly to us? Well, the game mode determines default classes for your game. For example, it's the game mode that assigns the default pawn class, meaning it determines which pawn we spawn in and play as. The game mode also handles spawning the player pawn at the player start actor in your level. And one thing to note is that for each level, you can override the game mode via the world settings. You can have different game modes for different levels. The game mode also has its own event graph and can execute blueprint code. And there's more to the game mode that's relevant to us right now. When we press play or when we start the level, the game mode executes some behavior. So what does it do? Well, when the player enters the game mode will spawn a player controller for that player. The game mode will then find the player start in your level, and then it will spawn the default pawn class at the player start. Then the game mode makes the player controller possess the default pawn. So this is what's really happening when we hit play. This is why we get this default behavior. It's the game mode that is causing us to spawn in as Unreal's default pawn at the player start. But we can change the default pawn class by creating our own game mode blueprint. So we want to create our own blueprint game mode class. In the content browser, we know that we can right click to create a new asset. So right now, I have a challenge for you. Inside your blueprints folder, I want you to create a new blueprint class. When Unreal asks you which class you want to create, make sure to choose game mode base. And I want you to name this class BP underscore game mode. So pause the video here and have a go at this, and then when you're ready, come back to the lesson and hit resume. So to do this, we want to make sure we're in the blueprints folder in the content browser. Inside this folder, we can right click to create a new asset. We're going to create a new blueprint class, and we're going to choose game mode base. And notice it says game mode base defines the game being played, its rules, scoring, and other facets of the game type. So let's choose this, and we're going to name it BP underscore game mode. Now let's double click on this to open it up. So the interface is the same as other blueprint actors that we've been working with, but I want to show you a little trick here. If we close the game mode and reopen it again, it gives us more of a compact view, showing us the game mode defaults that we can change. And look, we have a classes section here, and there is a default pawn class, and it's assigned Unreal's default pawn here. So we can simply drop this down and choose our BP player pawn. And this is all we need to do in here for now. We can hit compile and save, and we can close this out. If we hit play, we still don't spawn in as our default pawn, and this is because we haven't assigned our game mode. So there's two ways we can do this. Let me show you one way first. We're going to go up to settings on the toolbar, and this is where we can find the world settings. When we select this, it opens it up on a new tab next to the details panel, and there is a game mode section here, and look, it says game mode override. and it's set to none currently. So when it's set to none, it's going to assign Unreal's default game mode. But we can drop this down and override the game mode for this level by choosing our BP game mode we just created. And now when we hit play, we spawn in as our player pawn. But what if we don't want to override the game mode and we want to set our BP game mode as the main game mode across every level in our game? Well, to do this, we want to come up to Edit and then Project Settings. And here we have Maps and Modes. When we select Maps and Modes, it shows us default modes and it says default game mode. And it's assigned Unreal's default game mode, which is known as game mode base. But we can drop this down and choose our BP game mode just here. And now we can close this. And now any new levels we create will have our BP game mode assigned to them by default. Great, so in this lesson we've learned how to override spawning in as Unreal's default pawn, and we have done this by creating our own game mode blueprints class. So that wraps up this lesson. In the next lesson we're going to continue developing our player pawn. Hey, and welcome to this lesson, which is all about applying physics to the player pawn and also tackling the challenges that arise with the camera when we do this. We'll also be learning about how components retain their relative transforms. Okay, so we now spawn in correctly with our player pawn. Now, to make our player pawn move throughout the world, we want it to have a physical presence. So to do this, we want to apply physics to it. Now, there's going to be some issues that arise after we do this, but we're going to tackle those issues together. For right now, I'm going to start off this lesson with an early challenge. I want you to open up your player pawn blueprint, and I want you to enable simulate physics on the root mesh component. So pause here and have a go at this. Okay, so let's have a go at doing this. Let's open up our player pawn blueprint. And let's select the root component, which is our static mesh components here. Now, to apply physics to our sphere, we just need to come to the details panel, and where we have the physics category, we can simply check simulate physics to do this. Now remember, we have our camera components here, and we can see that the camera component is a child of the spring arm component, meaning the camera is attached to the spring arm. But the spring arm is also attached to our mesh components that we've just applied physics to, meaning that when our sphere moves and falls because of gravity, the camera is automatically going to follow it. If we come back to our level, we can take a look at this just by moving our player start up into the air, and we can hit play. So we can see that the sphere drops down and the camera moves with it. But let me show you what also happens. I'm just going to grab a cube off the basic tab on the modes panel. I'm just going to scale it up so it's kind of like a ramp here. Okay, and now let's take a look at what happens when I hit play. So the sphere falls, but it looks like the camera immediately starts freaking out when the ball starts rolling. So why is it doing this? Well, this is because the spring arm is retaining its relative rotation. So what do I mean by this? Well, by default, components will retain their relative transforms to the parent they are attached to. So for example, we have our mesh component with the spring arm and the camera. Now the spring arm is a child of the sphere. If the spring arm component is rotated by 60 degrees on its pitch, this would mean it's rotated 60 degrees relative to its parent. And even if the rotation of its parent changes, the spring arm will always be rotated by 60 degrees when compared to its parent. This is what I mean by retaining its relative rotation. The spring arm component is retaining its relative rotation to its parent. In effect, when the sphere rolls, the spring arm rolls with it, and this is what our issue is. We don't really want our spring arm to roll and rotate with the sphere. So is there a simple solution to this? Well, yes, there is. Instead of the spring arm retaining its relative rotation, we simply want it to retain its world rotation. So let's take a look at doing this. I'm going to switch back to my player pawn, and with the spring arm selected, we can see the transform section on the details panel. Now the values listed here are relative to the spring arm's parent, which is the mesh component. Now our issue is with the rotation method of the spring arm. We can change the rotation method or override it by clicking on this rotation here, and we can change the rotation type. It's currently set to relative, and this says rotation is relative to its parent. We can change this to world. And now when we come back to the level and hit play, we can see that the spring arm no longer rotates with its parent. Okay, but we might notice a bit of camera bobbing here with the spring arm. So the reason we're getting a bit of camera bobbing is because of the placement of the spring arm component. We want to make sure its relative location is in the center of the sphere. So to do this, I'm just going to change the location, or the Z location, from 67 to 50 on the spring arm, which centers it there. And now when we come back to the level and hit play, we no longer have any of these issues. Okay, great. So that wraps up this lesson. I'm just going to remove this ramp here and bring my player start back down to the floor. And I'm also going to hit File and Save All to save all my assets. So we're pretty much ready to start adding movement input into our player pawn. And that's just what we're going to start doing in the next lesson. So when you're ready, I'll see you there.